Hello, Intro to Robotics. So this video is going to demonstrate the next two circuits that we're going to ask you to create in Tinkercad. So you should have watched the previous video where we created this basic circuit and calculated the amount of resistance needed in our resistor for the circuit to work. If you haven't, please go and watch that video before you continue. Okay. In this video, we're going to show you how to add in different controllers for the LED light. At this point, if this was the completed circuit, we have no way to turn the light on and off because we haven't put a basic switch into our circuit. Okay, because everything is connected together without a switch, we can't actually turn the light physically on or off. So what we're going to do is we're going to actually build a circuit with a switch. So in the previous video, I showed you how to go across the gap, but remember, you can create these circuits any way you want on the breadboard as long as the circuits are completed in a loop that actually feeds back to the two terminuses of your battery. So in this case, I'm going to show you how to create the circuit a little bit differently. So resistance being part of our circuit, I can actually bridge the gap from the negative terminus into my breadboard. Okay. I can then connect my cathode of my LED into that same line. Notice, unlike the last video, I have not used wires to connect the different parts. I'm using the breadboard itself to connect the two parts together. Okay. I can then take, say, my switch, connect it to my breadboard. Notice what I have done with my switch is I've connected in a different row. So to bridge those two rows to allow electrons to flow, this is where I will place my wire. So what I have done is I've connected the anode of the LED through a wire, okay, into the breadboard that then connects it to the first terminal of my switch. Okay, so the circuit would then continue up through my switch to this row of my breadboard. What I need to do here now is complete the circuit by connecting this terminal of my switch to the positive terminal of my battery. Okay, so I've created the circuit by connecting the negative terminus of my battery to the negative terminal of my breadboard, connecting my resistor from the negative terminal of the breadboard into my first row. Okay, connecting the cathode of my LED into that same row, placing the anode of my LED into another row, connecting this row on my breadboard to this row on my breadboard, which is then connected to my switch, that is then connected to the second terminal of my switch, connected through this row in my breadboard back to the positive terminal of my battery. So I've completed my circuit. I start my simulation. What you will notice is because I have a switch, the switch is not on, my circuit is not on. If I then go and press on the switch, I close the circuit, completing the circuit, allowing electrons to flow through, and I can now turn my light on and off, my LED light on and off, by pushing the circuit. If I want to take a picture for me and Mr. Wei, I can press Shift on my computer, click on the circuit to turn it permanently on. And now I can go take my picture for Mr. Way. So again, just to show you again how it's done, I can share, I can download my picture, I can also invite people, I can copy the link, okay? I can then take this link and share it in my Google document to Mr. Way or Mr. Johnson, depending on who your teacher is. Share in folder, I drag and drop into my Google document, okay, and I create the link, okay. Now if I go back to Tinkercad, I'm going to want to create a new simulation, okay, so that when I click on that link, Mr. Johnson or Mr. Way, that will be saved and I can create a new circuit that can be shared with Mr. Way. So as a reminder, when we start off on a new program, we import all of our pieces, 9-volt battery. I'm going to take my potentiometer, which is the switch or dimmer switch that allows me to control the level of light coming from my LED. I take my LED, I take my resistor, I set my resistor to the proper amount of resistance as previously calculated in the other video, okay? And then I will create my connections the same as I did before. Okay, positive terminal to positive terminal, negative terminal to negative terminal. I'm going to color code my wires properly, red and black. Okay, I'm going to then build in the same way as I built the previous switch in. So I connect my first terminal of my resistor into the negative terminal, into a row of my breadboard, cathode of my LED into that same row. My anodes row, I'm going to connect to a row later on. Now, with a dimmer switch, what you'll notice is there are 3 terminals. We're going to use 2 terminals within this demonstration, but we are going to connect the third. The principles behind this will be explained later on when we get into Arduino circuits. But for right now, what we're going to do is we're going to use the middle wiper and terminal 2 to complete this circuit and just connect in terminal 1 as I will show you. So what we're going to do, we're going to connect our middle terminal. We're going to place it in our breadboard in the same row, row 15, as the wire that was connected from the anode of our LED. We're then going to connect terminal 2 to the negative, or to the positive, sorry, the positive terminal of our battery. This will complete our circuit. What you will notice, if I start the simulation, my LED light starts on, okay? It starts on and I can make it dimmer or brighter, but it is never actually turned off, okay? This is why we need to connect that third wire, and the importance behind this will become very important in Arduino, but for right now, we're going to take it and we're going to connect it to the negative terminal that our battery is connected to. What you will notice now when I start my simulation, my LED starts in off, and as I go, the potentiometer or the variable resistor allows me to control the amount of resistance in my circuit, allowing me to control the amount of electricity moving through my circuit or the amount of current moving through my circuit, allowing me to control the amount of light produced by my LED diode. Okay, Again, I'm going to export this new file for either myself or Mr. Johnston. I'm going to download my image. I'm going to invite people and copy my link. I'm going to open up my Google document. Okay. I'm going to import my picture. I'm going to copy the link that this file is associated with. Okay. I'm going to go back to Tinkercad, and I'm going to stop my simulation and close out of that assignment. Okay. Once you've completed those three basic circuits, so reproduce, replicate those three basic circuits using the videos provided. When you're done those, remember to go on and create the last two circuits that for this assignment. The RGB LED circuit, which has one RGB LED, uh, 3 slide switches to control the 3 colors, resistor, 9-volt battery, our RGB LED dimmer circuit, which contains one RGB LED, 3 potentiometers to control the 3 colors, okay, a resistor, and a 9-volt battery. Once you've completed those 2 additional circuits, make sure that you save your document, place it in your ePortfolio, so that me and Mr. Wei can assess how your abilities to complete those circuits. And while you're doing that, play around and have fun. Tinkercad is fun. You can build circuits in multiple different ways, just as long as everything is connected in the right order. Note, if you're having any troubles in building these circuits, please refer to the weekly learning document to see when the office hours are, and then grab the Google code from the D2L webpage or from the blog webpage to enter the Google meeting with the teacher that you wish to see at the time you wish to see. Thank you. This is the last tutorial for today. Hopefully we see you in office hours later this week.